Okay, you see at the top, I want you to find the area of that garden. It's one big garden that's been broken into two smaller gardens. So when I ask to find the area of the garden, I mean I want the area of the whole thing. How big is it? Go ahead, figure it out. Okay, I wouldn't care at all about what you're showing me as a solution to this, so don't worry about like, yeah, but how do you want me to write it? Like, in all seriousness, if you just want to jot down the answer, then just jot down the answer. But I want you to go through and calculate the area of that garden. Calculate the area of a rectangle. This should almost be reflex. You guys should almost have this as like gut instinct. All right. Length times width. So can we jot that down just a little bit and say at the very least we know that the area of any rectangle is one dimension times the other dimension. Okay. Now here's where I'm going to say I want to go through and I want to tackle this problem two different ways. Okay. I want to tackle it two different ways. And it's not because I think this problem should be difficult for you. I don't. I need you guys to know this problem would be assumed that you guys could answer this with no review. So now that I just gave you that green formula, what's the area of the garden? 8.
50 meters squared.
Perfect. Okay, we should have got 50. Now the question becomes, okay, how do we get there? And that's the whole reason why I want to tackle this problem, because you're going to see this problem and where we go. Okay. I took a big garden and I broke it up into two gardens. Give me something that we're growing in a garden. Give me something. All right. Carrots. So maybe I have carrots in that garden. Give me something else I'm growing in the other one. But like, I'm tired of like vegetables. I don't eat vegetables.
Tomato.
That's another vegetable. Well, I guess it's actually a fruit. Yeah, that's true. It has seeds. Yeah, but you're not going to get me just on a definition. But I 100% agree. Tulips. Okay, so now we got some flowers. So we got some tulips. Okay. I don't know. Should I put that in yellow or a different color? I don't know. There we go. There's our two gardens. Okay. Aiden, I'm going to pick on you a little bit because you gave me the answer of 50. Did you deal with that problem as two separate gardens, or did you deal with it as one big garden?
No, I put the 4 and the 6 together.
Okay, so let's write that down a little bit and say that our area in this case could have been the one dimension 5 times, and you guys know if I don't put any operation there that means multiply. And then we can take the one dimension added to the other dimension. Fair enough? And so I imagine that for most of us, that's what we would do. We would take a look at the big garden across the bottom and say, well, it's 10 meters across the bottom, so it's 10 by 5, and we would solve it following bedmass. And I love the fact that you gave me my units, and you remembered that area deals with square units. There we go. I like that. But could we also see that we could have come to the same thing dealing with two small gardens? So could we have calculated that then dealing with the carrot garden and the tulip garden? So let's go through and tackle the same thing. That, you know, your area is going to equal, well, how would you calculate? What is the area of the carrot garden? What's the area? 20. We can see it because we have a length of 5 and a width of 4. One dimension by the other dimension. So it is a 5 by 4. And then we can add to that, because we're going to put together the two gardens. Well, what's the area of the tulip garden? Are we good that that would be 5 by 6? Now, don't get hung up on, yeah, but wait a second, I thought area was length times width. And so shouldn't that have been 6 times 5? Does it matter what order you multiply in? No, so who cares? One dimension times the other dimension. And now we can clean that up a little bit. So we know that the area of the carrot garden is 20, and we know that the area of the tulip garden is 30, and we can combine that whole thing down to our 50 meters squared. Now, it might seem like a weird question, and it definitely will seem like a weird question, like it's out of the blue. Like, hey, this isn't what we were kind of playing with. But I want to make sure that we are good with where we go. So, can you guys take a look at the two problems that I put at the top of your page? I want you to look at those two problems at the top of your page. And can you see a pattern with how the left side of the equal sign gives you the right side of the equal sign? Okay, I want you to look at both of those examples and see if you can come up with a way that the left side of the equal sign gives you the right side of the equal sign. Jump into that next part of what you see on your page. So it's going to look a little weird, and I've just slid this down. Right below distributive law, and don't worry about the colors. The colors don't matter for you to get down in your note, but they are going to be applicable to what we talk about. So right below when you see distributive law on your page, I want you to get that down in big letters, like big variables. Don't write it really small, write it nice and big the same way I have. Like take up the width of your page. Because what we see with all those variables, that is a formula for some people. And the thing that scares me a little bit when you guys start to use the words like formula, and when a bunch of people, like I'm gonna bet and say that there's a lot of times where your parents say like, oh, well, when you do math in school, like you have to remember your formulas. For how many of you, as soon as I say formula, do you start to go memorize? Like I can say there's a few where you go like, oh, well, I have to memorize that formula now. So can I move a little bit away from formula when it's really just an idea? But the way we express an idea in generic terms looks like a formula. Like doesn't that look like a formula in a way? You got a bunch of letters in there and you got some operations. You can call it a formula, but I'd hope you would just call it an idea. The same way on the last pair, at the top of your page, I will never, ever, ever ask you guys to write down A equals L times W in any solution. The area of a rectangle being, or length times width, should be background information. It's a given, just use it. This is going to be background information. But that's what our theory would say distributive law is. So what I need you guys to do is to draw in a couple arrows. I want you to take a look at the left side of the equal sign and see how it becomes the right side of the equal sign. And maybe you can see in that instance that what we have is I took my A and I multiplied it by my B. And notice that gives me an AB term. We have that from 2 days ago when we dealt with multiplying and dividing monomials. We know how to multiply together variables. But now I took my A and I multiplied it by my C. I want you to draw on those two arrows. It's the only time I'm ever going to ask you to do it. But I think by me drawing on those arrows, you guys could look back to the top of your page and now you can see the pattern on the two problems I gave you. So look back to the top of your page, those two problems I gave you, and see if you can see that pattern. Because what I'm going to start to do is to challenge you with your BEDMAS. BEDMAS should have been like this overlying rule, this overlying concept that you have always had to follow since you learned it in grade 6. I must follow BEDMAS. BEDMAS is the basis for everything we do mathematically. And I want you guys to notice that BEDMAS seems to break apart when I give you an expression like A times B plus C. Can you add together B plus C? No, because they're different variables. Can you add together unlike terms? No, they have to have the same variable and the same exponent. They don't even meet the first check. They're not the same variable. BEDMAS would say you have to do that adding first because that's the operation inside the brackets. Well, what if we can't do that operation because we have variables and unlike terms? Well, then we have to move to the next operation, and that next operation is multiply, and we do have a way to deal with the multiplication. We get to that. So can you guys draw your arrows on those top two problems? That hopefully you can see that for us to go through and multiply one term by many terms, then we multiply by every combination of it. Now, depending on how you guys go, you might have a certain sort of pattern that you have up there. We used to have a teacher who used to call that rainbow. I will never, ever, ever call it rainbowing, but maybe you could start to see if you start to put a bunch of different colors in for all your arrows that you have, then the top of your page might start to look like there's a rainbow on it. What we refer to that as is expanding. You're expanding your brackets. So I want you to jump down to question 2 because we're going to pick up the pace. The question asks you to evaluate for x equals 3. We're going to tackle question 2 different ways. Okay, first way, if I was any of you and they asked me that question, here's my expression 2x plus 5. Evaluate it, so that means calculate it, if x equals 3. Then I would expect everybody to give me the blue solution first. You should be going, I'm going to sub in x equals 3, and I'm going to replace my x with 3. And now you just created a little bedmass question. Go ahead and calculate. Go as fast as you can. Do it in one line if you want. Like, jump straight to a final answer if you like. I would hope that we would be able to. What's my final answer? Just yell it out. There's only 5 of us. Just yell it out. 16. Now, maybe we put this line in as we're following bedmass, so we're going to do our addition first, and now we got our 2 times. There we go. Are you guys all pretty confident that the value of this expression when x equals 3 is 16? Pretty confident? Would you bet your life on it? I'd hope so, because those numbers are pretty easy to deal with. Can we get down an or? Because we're going to tackle that problem a different way. I am not saying that this is the better way to tackle it at all. It's just a different way to tackle it. I'm going to change the order in which we substitute. I'm going to simplify the expression first. Can you put together an x with a 5? No, because those are unlike terms. So let's expand in our 2. That expression then is equal to 2x plus 10. Notice what I did. I have my 2 times my x, and then I have my 2 times my positive 5. Now, how confident are you that this equals 2x plus 10? Would you bet your life on it? And some of you guys might be like, I don't know. Well, then let's sub in. So now we're going to make a substitution of x equals 3. And so when I replace my x with a 3, my suggestion to you, sub in your 3 in brackets. Notice what I get if I don't sub it in brackets. Does that not look like 23 plus 10? But you guys know that that expression was 2 times x. So make sure that we sub it in brackets to maintain that multiply. And pretty quickly then we can say, well, that's a 6 plus a 10, and there's your 16. Can I get you guys to get down both the blue and the green? Okay, you need down both. Is that okay for glare? Or is that bad glare? Harry has it for you, because you'll probably get it on the sides, okay? So what we should have confirmed then is, you notice you have the same value in both cases. Therefore, 2 times x plus 5 is equal to 2x plus 10. So what we need to do for the rest of this morning segment is we're going to jump in and we're going to expand a ton of brackets. We have to make this operation automatic for us. This is that next step in us learning this new language. Okay, I'm going to pop back to the screen if anybody needs it in a sec, but we're moving on. Okay, so what you see at the top of your page then, our instruction is to go through and expand. And so for us then, what we're going to do is we're going to apply that theory that says if I have something times multiple things, then I'm going to multiply by everything. So that expression says one thing times two things. The way I can deal with that is to take my one thing and multiply it by all parts of my other thing. So when we take a look at A, we've got 3 times x plus 4. I cannot collect like terms on my x plus 4, and so I need to then do my multiplication operation. And so when I go through and I expand that, I'm going to have my 3 times x and then my 3 times 4. Okay, we take a look at 2b. I now have 2, and I'm multiplying that by 2m minus 5. I can't collect my 2m minus 5, so now I'm going to go through and I'm going to do all my multiplication. So I have my 2 times my 2m and my 2 times my negative 5. Okay, I want everybody to pause the video right now and you work through those next 3 as fast as you can. Okay, and we're back. So for us to go through, then in question C, I need to multiply my negative 3 times every term inside the brackets. So I'm going to expand those full brackets, and there is my negative 15x squared. And then when we go to multiply our negative 3 times our negative 2x, we should be good that our negative times a negative gives us a positive. There's our 6, and then we have our x. And then when we go to expand our negative 3 times our positive 6, well, we get a negative times a positive, which is a negative, and 3 times 6 is 18. Question C should have given us a little confirmation. We can pick up the pace a little bit through D. We're going to multiply that 2x in by everything. And so we should have a little confirmation on D. And now E would be our doozy for this category. So for us to go ahead and multiply that in, we should now be able to deal with our 10m cubed n to the 4th minus 35m to the 4th n squared. So I would argue to you guys that E is probably as ugly as what it would come for us dealing with all of our integers. Okay, let's take a peek at the next section. Take a look up at the instructions now because I've given you a slightly different instruction. All the other questions said expand. What does that say now? Expand and simplify. Expand and simplify is often the same thing as expanding, but I'm being very explicit. Your instructions tell you 2 things. Expand, then it tells you simplify if you can. So let's do it in its bits. I want you guys to see what I think your first line should be on A. And this is where we're going to get to some double sign stuff, and we get to kind of work through double signs. But when you guys take a look at A, can you collect an x and a minus 4? No. Can you collect an x and a plus 2? No. So we cannot do the subtraction in the first bracket or the addition in the second bracket. We can't. So we go to our next operation then, and can you guys see your 2 multiplication operations in that expression? We've got multiply in between the 2 in the bracket, and we have multiply in between the 3 in the bracket. Now, I'm going to write something down, and I know it's going to look weird to you guys. I get it. But I want you to imagine that happy face equals x minus 4. Okay? I just want you to imagine happy face equals x minus 4. And I want you to imagine that star equals x plus 2. Then can you guys see that that expression is really 2 times happy face plus 3 times star? And maybe now you can really see your bed mass in there. Can you see that you have 3 operations? You have multiply, and add. So which one of those operations do you have to do first? Multiply or add? Multiply. So I'm not asking you to do anything that you would not have done in grade 6 with question A. But it just looks different because we're now making those somethings a little bit uglier. So the faster we can start to read question A as 2 times something plus 3 times something. That's all x minus 4 is. Do you know the value of x minus 4? I have no clue because I don't know what x is. Do you know the value of x plus 2? No clue. So I'm going to replace those with the word something. 2 times something plus 3 times something. Well, I know I have to do my multiplications first. So how do we multiply one thing by other things? We expand. Everybody should be able to expand the first bracket. But I can't touch that addition symbol yet because I know BEDMAS says do it at the end. But I'm not going to do this. Well, since I can't do the add, I guess I'll write it down. Don't. Because as soon as you do that, you're now introducing double signs. Don't. Now, expand in the next term. What sign is the 3? It's positive. It's always the sign that comes out in front. Well, let's expand in a 3. Okay, well, what's positive 3 times x? Positive 3x. And what is positive 3 times positive 2? Positive 6. I love the blue line as your first line. Can you guys make sure you get that down? And once you have the blue line down, then doesn't that look like a problem from yesterday morning? There's your collecting like terms. Do you see anything in that blue line that you can collect? Yeah, give me 2 terms you can collect. Hey.
2x and 3x?
Yeah, what's 2x plus 3x?
5x?
There's my 5x. So I can collect my x terms. Do you see anything else you can collect? We should see our constants. You have your negative 8s plus 6. And so we can put those together. And so my negative 8 plus 6, there's my negative 14. And we're good. Right? If you were nodding with me that that is right, then I want to hit you with a marker. How is negative 8 plus 6 negative 14? You guys are killing me. Yeah. Do you know how many of you guys, I saw some of you guys flip over your pencil and start erasing probably when you wrote negative 2 down, and you changed it to negative 14. If you lose $8 and then you find $6, are you up or down money? Down. How much are you down? Just 2. There's your minus 2. Oh, you guys are killing me. And there we go. So, when you guys take a peek at that, look at what your blue line is. Your blue line is your expanding. Your red line is your simplifying. Okay, I want you guys to go through B on your own. Okay, start to finish, expand it, and simplify it. I'm telling you that I'm expecting maybe 2 correct answers. Maybe 2. Okay, I'm expecting 3 of you to be wrong. So, we expand in the 4 on the first bracket. Okay, I'm expecting I should have all 5 of you correct to that point. Okay, we had no problem expanding the first one. I'm expecting 3 of you to have that on your page. Who has that on the page? Just tell me. Oh, it was 4. Shoot. Because that's wrong.
Wait, I don't have the negative.
No, I have positive 8.
Hold on a second. If I say, do you have that on your page? This is what some of you guys did. Yes, I do. Oh, but wait a sec, but I don't have that. Well, then what the heck is this?
I looked too quick. I didn't see that.
Like you guys are in that mode where it's like somebody asks you a question and you think you have to give an answer like right away. Like you're allowed to think.
No, I thought
Like, you're allowed to. Well, same thing. Negative and a minus, same thing. But what's my mistake? What sign should the 18 be?
None. You don't need a sign. It's positive.
You absolutely need a sign in between. You better have written down a positive.
Oh,
If you write 6m and 18, then if I don't see an operation in between there, what operation does that mean? Multiply. Now, yeah, shoot, it shouldn't be multiply in there. It should just be addition. There is your answer in blue, and that is now correct. I'm telling you guys that common practice is going to say your most common mistake is going to be here. That you make a sign mistake. Fair to assume? How many people had 18 written at the end? Everybody. How many people had negative 18 written at the end? A lot, because we missed that sign mistake. Be very careful. A negative times a negative, So anytime you guys see that, slow down a little bit. Make sure that you don't make a silly sign mistake. Then speed up on your calculation. Okay, we should be okay to collect like terms. 4m minus 6m is a negative 2m. And a 20 plus an 18, 38. If you got down to that, then you're good. Now, I'm going to tell you that in a lot of instances, if you were to check your answer to that problem, it's not going to look that way. And I just want to make sure that I give you a little bit of a form issue. Guys, big picture, this year, we're not going to really mind if you write down negative 2m plus 38. Are you guys good that that is standard form? It's decreasing degrees of x, or of the variable, in this case m. However, can you guys maybe see that that's unsimplified? How many signs did I write down in red? Can you see I wrote down 2? If I rearrange that line and I wrote the positive 38 first, do I have to put down the positive? No. But I do need the minus 2m. That after grade 9, you're going to see 38 minus 2m more often because it's actually better form, because it's more simplified. In here this year, we don't mind which one you write. In the future, though, it will matter. So if you want to, get into that habit now. Okay, take a look at C and D. I'm going to ask you guys to work your way through both C and D now. You've seen all the little look-fors. Now your job, take your time, expand your brackets, and then collect like terms. So we go through, we deal with a little expanding. You're going to take your 2 and you are going to multiply it into everything inside that bracket. So I have a 2x squared minus a 6x plus a 4. Hopefully everybody matched up on the first 3 terms. Now, the second bracket, I notice there's a minus out in front, so I'm going to pump the brakes a little bit. I'm going to slow down, and I'm going to make sure that I don't make any silly sign mistakes. Negative 3 times x squared, negative 3 times positive 2, and a negative 3 times a negative 4. If I was to anticipate a mistake, it would have been that you guys would have had minus 12 on the end of that expression. Okay? Keep in mind, one quick way to think about multiplying by a negative is you multiply by the number and change the sign. To multiply by a negative, we change the sign. Now that you have that, now we collect everything. Okay, so I can put together my x squared terms. There's a 2x squared minus a 3x squared, so there's a negative x squared. I can put together my single x terms. A negative 6x minus 6x is a negative 12x. And I can put together my constants. There is a 4 plus a 12, and we should have got down to that blue expression. If you guys have your negative x squared minus 12x plus 16, you are perfect. How we do? We getting there? Hopefully. What I want you to do is take a look at, if you had something different, now we have to see why we have something different. Was it a silly little mechanical mistake? Like, seriously, you took 4 and you added it to 16 and you wrote down 15, something like that. Like, who cares if you make a mistake like that? That's human error mistake. Who cares? But was it a concept mistake? So I want to make sure we're very good. I could have seen some people who would have thought that those 6x terms would have canceled out. I would have had that. I would have expected to see that. Because we calculated a different value, though, that's a theory mistake in this case. If I lose $6 and then I lose another $6, then I lost 12. That's a theory thing. Okay, maybe I've caught up to you on D. D is just more. Expand it. 15x cubed minus 25x squareds plus 20x's. There is me taking my first term and expanding it into all that next factor. Well, now when I look at my next expansion, I notice it's a plus 2. So I don't have to worry about my signs because I'm going to multiply by a positive. So a 2x times a 6x is a 12x squared. And a 2x times a negative 7 is a negative 14x. Okay, if you were able to get that blue line, then you understand expanding. That is good feedback to you. You understand the topic for today. You do. You got it. If we struggle to get that, then we're missing stuff from today. So then we need to get some extra practice or we got to ask some questions. The next part, though, about us simplifying, this is telling you you're missing stuff from yesterday. We can go ahead and we can collect everything. I only have one x cubed term, so I have nothing to pair that up with. I do have an x squared term and an x squared term. So this is what I'm talking about when I'd say, if you wrote this down, that's a theory mistake. It's not theory about collecting. It's theory about integers. Like, that wasn't by mistake writing down 2 times 3 is 5. Like, that's a human error thing. But that's an integer mistake, and I'm hoping that nobody has 37 down there. If I lose $25 and I find 13 or $12, then I'm still down 13. That takes care of my x squareds. Now I have my single x terms. There is a positive 20 minus a 14. And there is a positive 6. What? 6x. Okay, I want to walk through E and F together. But all I want you to do is put down your first line for E and then stop. Okay, you put down your first line for E and stop. Don't put down a second line. Okay, give it a shot on E. So if you were to take a peek at the first line for this one, if you wrote that down on your page, you should have failed grade 6 math. Because what's the big topic in grade 6? Bed mass. Can you guys see that if I wrote down that green, I just broke bed mass? And that is going to be a huge mistake for us because we go too fast. So I want us to just make a note. Don't get into a habit of just doing math. Look at the instructions and you're good. Take a peek at your original. What operations do you have in there? There's really only 2 operations. You have 5 minus something. It's really weird, but if I asked you how many terms you had in E, you guys should tell me 2 terms. And look how ugly it is. It looks like there's way more terms than that. There's only 2 terms in E. So that says take 5 and subtract something. Now, that something is made up of 2 terms. I have my 7 Then I have multiplied by 2m minus 3. Okay, can we see that the only operations in that question are subtract and multiply? Take 5 and subtract 7 times something. BEDMAS says, what do you have to do first? Subtract or multiply? Multiply. So, it's going to be tempting to do something with that 5. You cannot touch that 5 yet. And instead, our first step then has to be, we need to take that negative 7 and multiply it in. So what's a negative 7 times 2m? Negative 14m. And what's a negative 7 times a negative 3? A positive 21. Now that you have that, now we collect whatever we can. The rest of that problem should be pretty basic for us to be able to go through. Maybe we get to that because you put your 5 together with your 21. Or maybe we're already writing things in great form and you just wrote it as 26 minus 14m. Okay, put a little star by that if your instinct was to take the 5 and subtract the 7. Okay, that's telling you we got to take a look at it. There. Oh, is it? Put a little star on that question then and make sure we're good. Okay, take a look at F. Does F look weird to you? I think it should look a little weird to you guys, a little bit. And I'm going to take blame for why that looks weird. Because in like 9 problems for today, I've already trained you to an instinct, and I have to break that a little bit. There is a common form, okay? It's just a common form. It's not proper form. It's just common. That says that if you're going to multiply a number of things, 5x minus 8 is multiple things, by one thing, then we tend to write the monomial, the one thing, out in front. Like already after doing just a few problems, how many people does the blue look more normal than the expression I gave you? It probably does. They mean the exact same thing. Does it matter what order we multiply in? No. So when I give you that big, ugly, and I'm being sarcastic, expression in F, and we see that multiply by 9 on the end, we need to make sure that we are good, that for you, you can just expand brackets. Like there's no rule that says like, yeah, but you always expand to the right. No, not at all. I do the operation. And so the operation between those is multiply. So we multiply. 5 times 9 with my x. Negative 8 times 9. And you are done. And there you go. So nobody's going to be thrown off then if all of a sudden you just see an expression that has the monomial at the end. Doesn't matter. Expand backwards, you're good. Okay, I have left you. I think I've caught up to you with the big ugly problem, which finally lines us up since I goofed up and putting all this together. Okay, we're now at a good point. So what I'm going to ask you guys to do is now you're going to jump in and you're going to play around with some practice. So